All right, we have another vector decomposition problem. We want to write f in terms of e hat 1 and e hat 2, but this one looks a little bit different than many of the others because I have this angle theta that describes the orientation of f, and I have a different angle phi that describes how e hat 1 and e hat 2 are arranged here in space. So it's going to be a little bit different, but the general principles are the same. So let me sort of show right here. So what we're going to do is we're going to construct a forced triangle as before, where f is the hypotenuse of that triangle, and then the other two sides of the triangle are parallel to the e hat 1 and e hat 2 directions. So in particular, if I start with at the tail of f and come out, I can come out this way along the e hat 1 direction, right, for some vector, and then I can go this way along the e hat 2 direction, parallel to there. And since it's arranged tip to tail, the sum of these two pink vectors would add up to the f. So that's that first step. Now what I need to do is identify an angle in this thing, right? And I want to what I really want is an angle, and what I really want is an internal angle in this vector triangle. So I'm going to, for my internal angle, I'm going to pick this one I have right here. I'm just indicating it in blue. Now this angle right here is the angle between sort of where vector f is going and this e hat 1 direction. So this angle right here that I have in blue is this angle right there that I also have in blue. Those two are the same. So how do I write that angle right there in terms of angles that are given? Well, here we do just recognize a little bit of our own geometry from middle school or whenever it was. This angle theta right here, if I extend these two sides where I define theta, this one just goes up vertically, this one goes in the direction of the f. So this angle theta right there is the same as this angle theta right here. I'll give it the same name, theta. So this angle that I'm interested in terms of theta and phi is going to be theta minus phi, right? That blue angle, theta minus phi. Cool. In fact, I've got it labeled right there, theta minus phi. So now it's just simple trigonometry. So the e hat 1 component was this one right here, and it's the side adjacent to this angle of interest. So therefore the e hat 1 component is going to have a cosine there. The e hat 2 component, which is this direction, boom, that direction, that's the opposite side from the angle of interest, so that's why I have a sign there. And then to get the pluses and minuses right, notice this e hat 1 component is in the positive e hat 1 direction, so I don't need a minus sign right there. And then notice also that the where are we? The e hat 2 direction is in the direction, excuse me, the e hat 2 component of my vector is in the e hat 2 direction. So again, I get a plus sign right there. And therefore this is my solution, so I'll stick with it.